Hello everyone. For this tutorial video, I like to explain how parallel RLC circuits work, which uses the same thought process as discussed in the last video, combined with the ideas of parallel circuits rather than series circuits. In particular, if we were to draw a diagram to organize all the voltages, currents, and resistances like we normally do for the circuit, we would first start by stating that the voltage is equal throughout all the components and is exactly equal to the voltage in phase of the source. Then, we'd calculate the resistances either using given resistances, like for the resistor, or using reactance formulas, like for the capacitor and inductor. And then finally, we would calculate the current, although obviously for the current calculation, we'd have to pay attention to the fact all three components have different phases, so it will affect the phase of the current as well. Once we calculate all the individual currents using Ohm's law, we can add all of the currents because of how parallel circuits work. And then for the total resistance, we can either calculate it as total voltage divided by total current, or use the total resistance rule for parallel circuits without using currents or voltages. Although obviously we would use Z for impedance instead. Now that I've explained how to solve problems with parallel RLC circuits, I can explain how to solve series parallel RLC circuits, which would use more complicated methods than either simple series or simple parallel circuit formulas, exactly like the problem with series parallel circuits with just resistors investigated earlier. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.